Okay, welcome in. Let's dive right into this masterclass explainer where we're going to dissect Cambridge computer science exam questions with absolute undeniable surgical precision. Today we are donning our virtual scrubs, washing our hands, and stepping directly into the surgical theater. We're examining a topic that is quite literally the lifeblood of the Cambridge AS and A-Level 9618 computer science syllabus. I'm talking about output to console in pseudocode. Now listen, whether you are dealing with foundational syllabus codes like 0417, 0478, 0983, 0984, 2210, or you're tackling the beast that is 9618 today, the strategy is universal. If you want to achieve those top grade boundary-breaking marks, you need to treat these exam questions not as some frantic guessing game, but as a precise, methodical operation. I see two types of students all the time. Let's call them Alex and Sam. Alex overloads every single answer with raw computer science facts, totally ignoring the required analysis. It's just a data dump. And then you have Sam. Sam rushes the paper, panics at the sight of code, and completely misses the specific command word requirements. Both of these approaches result in a paper covered in red pen marks. Today, we change that. We are turning those red marks into green check marks.
So here is the absolute most crucial point you need to understand right out of the gate. Mastering console output in pseudocode is completely non-negotiable for your success. Why? Because it is tested without fail every single examination series. It does not matter what year it is, it does not matter what variant you are sitting, you will face this topic. You cannot hide from it. And honestly, once you truly understand the framework we are going to cover in this session, you won't want to hide from it. It becomes highly predictable. It transforms from this terrifying wall of text into a fantastic, reliable opportunity to secure consistent marks. Think of it as your anchor in the exam. When you open that paper and see a pseudocode trace or an output question, I want you to smile, knowing you have the exact blueprint to solve it.
Here is our playbook for today's session, structured exactly how the principal examiners evaluate your answers. We're taking you from core theory to fail-safe exam strategies. We'll hit theoretical foundations, then move into the procedural framework, dive deep into critical analysis, reveal the top examiner warnings, and wrap up with a final strategy that you can use tomorrow.
Let's start with Section 1, the foundational architecture. This is what proves to the examiner that you actually understand what your pseudocode is doing, rather than just blindly guessing.
You have to realize that examiners are explicitly targeting these three specific cognitive domains. They aren't just looking for a random output string, they are testing your underlying mental mechanics. It's not just about what you know, but how you systematically apply evidence-based reasoning. Let's break this down. The Cambridge assessment objectives require you to first demonstrate knowledge and understanding. This means knowing the definitions of variables, understanding loops, and recognizing the causal relationships in the code you're reading. This is where our student Alex usually stops, right? Just dumping knowledge. But you have to move to step 2, application. This tests your ability to take that core knowledge and actually use it in the specific unique scenario provided in the exam prompt. And finally, the holy grail, analysis. This demands that you break down the complex problem, evaluate its moving parts, and draw logical, undeniable conclusions about what will actually happen on that console. You need all three to get the marks.
Now, what's really interesting about this slide is that it reveals a massive secret pulled directly from the principal examiner reports. And before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so back to the secret. Here it is. Pseudocode absolutely does not exist in a vacuum. Integrating it with other syllabus areas is exactly what unlocks those top-tier A-star grades. The highest-scoring candidates across the world don't just look at a pseudocode snippet in isolation. They connect it to overarching theoretical principles. They show a holistic understanding of the entire computer science landscape. If your given algorithm is outputting something to the console that is based on a database query, or maybe a specific complex data structure like a 2D array or a linked list, explicitly mentioning those cross-topic connections in your written explanation is what elevates a good, average answer into a phenomenal one.
All right, let's move to Section 2, the technical methodology. We're going to see exactly how this builds into the specific steps you need to follow when analyzing a complex problem.
Think of this as your internal mental engine. Before you even think about writing a single line of your answer on that exam paper, your data interpretation skills must flawlessly move through this specific three-part pipeline. It's like a built-in interactive workshop you do in your head. First, you extract.
For example, you might need to read and interpret raw binary representations or complex data tables right from the problem description. You are just gathering the raw materials. Next, you calculate. This is where you mentally or physically on scratch paper perform the operations dictated by the pseudocode, loops, and conditionals. Finally, you conclude. This means taking those computed